All right. So, the key to remember, you know where it is, right, under programs, Jack? It's not under stat, it's under PRGM, the program button, which is directly under the stat button. I don't know how to hardwire them into to the program screen. So you're here, and you just have to go find the one that's called Systems Calc, which is down at the bottom for me. There she is. Sample size calc.
Actually, I don't.
Oh, you don't have it. Well, here's how you use it. I'll hook it up to you in a second here. So you run it, and the first thing it asks for is the confidence. What do we usually use?
95.
Tell me why?
Because it's the happy medium.
Anything less than suspect. Good. I like that. Anything less than suspect in industry standards. Why don't we just go higher? Why don't we go to 100%?
You don't count margin of error.
Say that again, Rosie.
You have to count margin of error.
You do. Why don't we just go to 100% and form that margin of error? This is kind of a silly question, which we did answer last time, and you might remember why we can't do it. Well, we can do it, but it's stupid because... Oh, go ahead.
0 to 100%.
Because then every confidence interval would be, I am 100% certain that between 0% and 100% of whatever I'm studying is happening. And then it's like, okay, yeah, you're right, except I can't use that at all because I don't even know what that means. That doesn't narrow it down. So let's back it off for a smidge to 99.9%. What's wrong with that? What's wrong with maybe going 99.9%?
Same problem.
The same problem, not quite as exaggerated, but maybe now it's 1 to 99%. So you're sure it's not 0.5% or something along those lines. 95 is a nice workaround between a balance of two kinds of errors we have not talked about yet. We might talk about it today, more likely Tuesday. But there's something called a type 1 error and a type 2 error. A type 1 error is when, well, we'll get into that on Tuesday, I don't get too far into that. But one's a false positive, type 1, and one's a false negative, type 2. And a 95% confidence does a nice job of minimizing both, on average. On average. We stick with 95. But here's what I really want to ask you right now. What does it mean to be 95% confident? So when we say something like, I'm 95% confident that the proportion of whatever I'm looking for is between 7% and 12%, you know what? Let's write that down. We'll come back to this program in a second, Jack. I'm not trying to get us derailed here. No, it's good, it's good. It's good to do it again anyway. But let me ask a question. Suppose we've created an interval, which we can create here momentarily, and say we're 95% confident that whatever we're studying, and whatever we're studying is some proportion in the population, whether it's the proportion of those who support a new law, whether it's a proportion of those who have admitted to something or the other, whether it's the proportion of children who suffer some kind of a rash, breakout from a certain dietary restriction or dietary indulgence that they shouldn't, something like that, right? Suppose we're 95% confident that whatever that proportion we're studying is between 7% and 12%. Mimi, go.
I'm pretty sure it means that 95% of the time in the study it will fall between 7% and 12%.
Good. Can I change your phrasing just a smidge, a tiny bit, and it's really nitpicky, but I like to keep this bit as exact as possible. I love what you said. Love what you said. If I do 100 studies, I can expect on average 95% of the intervals I get to contain what I'm looking for, which is almost exactly what you said, Mimi. I mean, almost exactly what you said. But the reason I said it the way I said it was I gave the point of repeated studies, where you said 95% of the time in my study. The reason, can anybody see why I'm picking on that particular word? 95% of the time in my study. It's an extraordinarily subtle point. Why should I say it the way I said it? If I do a study 100 times, then I catch it 95, versus in one study I catch it 95% of the time. Can anybody see why? Chris, go ahead.
You need the sample size to compare?
Think more general than that. You're thinking very specific, thank you, but think more general. If I do a study and get this interval, where's the parameter that I'm studying? Either in the interval or outside somewhere. So it seems kind of hard to say that there's a 95% chance it's in, because it's either in or it's out. Does that make sense? And for any study, it's either in or it's out. But for confidence, you two pay attention, this is important. For confidence, the whole definition of confidence is if you do it repeatedly, 95% of the intervals that you create catch what you're looking for. Some do, some don't. On average, 95% of them do. So that's why I'm adjusting your language just the tiniest bit, Mimi. And think of it like you're thinking of it, because you're correct to think of it that way. But to be formally correct about it, and I won't pick on this, of course. I'm not talking about an in-class assessment. I won't say, give me the definition of confidence, blah, 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 blah. I'm going to have you guys say, I'm 95% confident that, you know, the approval rate of Senate is now at an all-time low of 3%, or something along those lines. We'll use that on your first exam, just because they'll probably be shut down by then anyway. Still. Fair? Fair for all you guys? Beautiful. Tell me all you can about the statistics in this study. Some things you can't tell me. Some things you can't tell me, but there are some things you can tell me as well. So, what's one thing you can tell me? Puberty.
Can't fall below 7%.
Nice!
Or above 12%.
Drew, I am 95% confident that it is not below 7%, nor is it above 12%. Love that. 95% confident it's not below 7, nor above 12. So I'm 95% confident it's not 6, or 5, or 4, or 3, or 26, or 50, or 71. Can I distinguish whether it's 8 or 9? Can I distinguish the difference whether it's 8 or 9? No, because they're both in there. So all I know is I'm 95% confident it's between these two values. And guys, don't get hung up. This is a stat class, not a math class. Don't get hung up with parentheses versus brackets. A lot of stat students get worked up with parentheses versus brackets. We use parentheses by default in here. Your TI does as well. And mathematically, there's a difference between a set of parentheses and a set of brackets, right? And what is that mathematical difference? Kayla, go ahead. Go ahead. Yes! So what this basically means is it can get all the way down but not touching 7. So 7.0000000000000000001. But a bracket means you can actually get to 7. Don't worry about the difference. That difference is a precision difference, which is taken care of, as Chris said, with sample size. We can deal with that, and we will deal with that in this class. What can you tell me about the sample results? What can you tell me about the sample results? Interpret one of the sample statistics for me based on this. Since you know this is the confidence interval. And ignore goofy rounding, just assume it is 7 to 12. Well, what are you thinking?
Sample mean is 9.5.
Boom! You guys know that p hat has to be 9.5%. Will, how did you get that so quickly?
Between those two values.
Yes! Your data's center is centered on that interval. So since 7 to 12 is a distance of 5, center is halfway between that at 9.5. You can actually draw this. I like drawing them. I think it's a nice idea to kind of have them sketched out. So if we have, let's just put some numbers. So put 4% here, 13% here. Again, you get 5, 6, 7, 8, 9, 10, 11, 12, 13. Put 13 down here. So you got 5, 6, 7% here. 8, 9, 10, 11, 12% here. So your confidence interval stretches from here all the way to there. And who lives in that interval? 95% with 95% confidence? Who lives in that interval with 95% confidence? Say that again, be brave. Wait. Yeah, I was going Danielle, Lindsay. Okay, I got a second guess myself. No, Lindsay, go ahead, nice and loud. Well, 9.5 definitely lives in that interval. But 9.5 is what the statistic of the parameter. Is the statistic with a parameter. And why do I care? It's definitely the statistic. And we know that, don't we? The statistic is descriptive. Because we ran a study, collected the data, and divided successes by sample size and got 9.5. That's that 9.5, and yes, Lindsay, that 9.5 sits right, 9.5 right dead center with a pen that breaks, preferably. Boom, 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 boom. There's p hat. There's p hat. But if I form these intervals, 95% of the time, who else lives in there? And I'll give you a hint. It's got something in common with p hat. and it also doesn't wear a hat. Which means it's just P. Why do I think of something clever? Damn it, I can't think of anything clever. Why do we care about little p? Why do we care about little p? Go, Will.
It's the parameter you're trying to figure out.
Exactly, that's the whole point. I'm trying to estimate that. That's what we're doing in the study. We don't know what it is. It's out there somewhere. Somewhere out there is the proportion of 6-year-old boys that get hives as a result of eating chocolate ice cream, i.e. my son. I don't know what that proportion is, so I do a study to find out. I still don't know what that proportion is, but at least now I have this. Pretend those are the same distance too. That's horribly inaccurate. Let's move that 12 over. Yeah, sorry, YouTube world. So now I'm 95% confident that it's between these two values. So I've gone from knowing nothing, from knowing that it's between 0 and 100%, which is guaranteed but also useless, to being slightly less confident, 95%, but at least having it within, what percentage, how many percentage points of p hat? Within 2.5. This is Michael, right? Michael, within 2.5, and 2.5% is what in this study? Go ahead.
Deviation.
Good. You can call standard deviation. Its margin of error is the inferential term. Standard deviation is more a descriptive term. That would be one standard error. This is 2 standard errors, and any number of standard errors is your margin of error. Margin of error is usually 2 of them. That's why we use 95% confidence for two distances away from center. So that's what that is, at 2.5. So that means 1 standard deviation, if I was to ask you, or 1 standard error would be 1.25, but that just gets mathematical. I could also ask what the sample size was. I could do that. I won't, because it's a math problem, not a stat problem. Because you know everything you need to know to figure out the sample size. You know the margin of error is 2.5. You know p hat is 9.5%. You know that q hat is whatever's left, which would be 90.5% to get to 100%. So you could solve that for n. And I've made students do it in the past. And then they start dry heaving. And I stop. And that's what the video, not dry heaving, I'm not going to video myself dry heaving, but that video I'm going to post for you guys tomorrow will show the derivation of the sample size from the margin of error calculation. So you can actually see it if you care. Some of you won't, and that's fine. Good so far? Yes? This is kind of ringing a bell from Tuesday? Yes. So Jack, back to your question. It sounds like you figured it out, but let's run it anyway, just to make sure we're all on the same page.